Hi, I'm Paul and I'm going to give a quick introduction into our quantum editor. For composing circuits, we can simply drag and drop gates to the wires below. For deleting them again, we may now place the identity gate on top of existing ones. In every case, our content will be persisted on the browser session storage, so even if we do a full refresh, everything's still available. We can also clear the whole circuit or save to or load from our local disk. Lastly, we may also export in several formats. For instance, when choosing Qiskit, we get a full Python snippet of our circuit. For executing the circuit now, we have two options. First, we can run the whole circuit to see the final result. Okay, so now the progress indicator moved to the end and our execution stopped, so let's have a look on the visualizations. We have 4 of them and you can find them below. We can either scroll down to have the full screen available or click this button to open the side-by-side view. In all of our visualizations, we state the probabilities and phases of all possible states. Here, in the bar plot, we are representing the phase as color and the probability as height of the bars. In the Q-sphere, all states are aligned by the Hamming distance on the surface. The phase is still the color, while the probability is the length of the vector. They are normalized, hence the equally long vectors mean here that both outcomes are equally probable. The state cube is another cool visualization we have. The phase is again the color, but the probability is represented as the size of the inner cube now. Since the dimensions of the state cube grow linearly with the number of qubits, we can only visualize 4 dimensions. So the first 3 as usually known, and the 4th dimension is done by a kind of tesseract visualization. The phase state cube is similar to the state cube, but instead of the infill, the probability is here represented by the size of the inner circle. The phase is not only the color, but also the watch hand now. We have one more visualization left, which you can find directly inside the circuit. The phase disks represent the state of a single qubit. The phase is the position of the watch hand, the probability the degree of infill, and the purity is the radial offset from the middle of the circle. But the coolest feature is our play pause button to debug our circuit. We can stop at any given location and resume later. You can see that the color becomes a bit more matte during animation, and we are not just interpolating linearly here, but instead use the mathematically correct way to interpolate. Easily spoken, that means that for generating one animation step, we partially apply 1/64th of the desired gate. So we do this 64 times per gate, so after 64 partial applications, we have like one complete step. And to start the debugger over, we can just hit the run all button and then start from the beginning.